Okay, next is the invited talk is from Speaking, and another team that gained a very significant achievement. And I think who is the presenter? Minqiang. Okay, can you hear me?
Yeah, can you hear me?
Yes, go ahead.
Okay. Okay. Now can you see the my slides?
Yeah, good.
Okay. Thanks to Professor Wang. And I'm Minqiang from Speaking Technology. We are a startup and focusing on the speech and language processing. Today I will give you all a presentation about Speaking team system description for CNSRC 2022. And here's the overview of my presentation. Datasets, system description, training strategy, and results and conclusions. For the task one fixed track, only the CN syllable.t dataset was used, and for the SVE open task one is open track and task two SR open track, we use our internal large scale corpus and which is more about 200,000 speakers, and we also use Vox syllable 1 and Vox syllable 2 and CN syllable.t. So the total number of the speakers is about 245,000. For CN syllable.t, we apply a threefold speaker tabulation to generate extra twice speakers by using the SOX tools. And we also use card-based data augmentation, including reverberation, additive music, additive noise, and additive bubbles. So after augmentation, the amount of data is 5 times as the original data. Yeah. we extract 41-dimensional FBank as features. The window size is 25 milliseconds and the hop is 10 milliseconds. We do not use VAD in our systems, and all features were processed using CMN in our systems. We utilize 3 kinds of networks in our systems: ResNet, RapVGG, eCappa TDN. Our network is composed of frame level backbone, pooling layer, matrix learning modular, and loss heads. The structure of the VGG as one of our network is illustrated in the left. And the FBank features are fed to COUNT-D layers, and then 4 rep blocks are repeated. Statistic pooling layers is followed to transfer the frame level representation to utterance level representation. And FC layer is used as metric learning module, where speaker embedding vector can be extracted. At last, a large margin-based softmax loss is applied. We use a modified ResNet version as our backbone, where the stride of the first block, where the stride of the first block is set to 1, and while the others are set to 2. We use ResNet 34, ResNet 74, and ResNet 101. And the baseline channel is set to 64. Sorry, here's the RapVGG. Besides the ResNet, we use RapVGG structure, which is also first proposed in the speaker systems for Vox SRC 2021 challenge in the speaker recognition fields. And this is as one of our backbones. And we can see from the left of the of the picture, we can see that in the training phase, RepVGG has multiple branches, which makes it more representative than ResNet. While in the inference phase, these branches can be merged to 3 times 3 branches, and so now it's a plain structure. So the speed of reference is very fast. We select RepVGG A2 as our network. We use MQ, MHA pooling methods and AM softmax as our loss function. Because of the noisy training data, so the subcenter method is applied in our system in order to reduce the influence of noisy examples within classes. You can see more details in the papers listed below. In the training phase, we use 2 stages training strategies. For the first stage, we train our model from scratch. All the data are fed to training, and the chunk size is 200, and the margin of AM softmax is 0.2, and the number of subcenter is 3. For fixed track, the number of nodes in the softmax layer is 8,235, while for the open track, the number of speakers is about 245,000. For the second stage, we do large margin refinements. We drop out the speed. We drop out the speed permutation data, and so the number of speakers now is 2,745, and we also turn off the subcenter, increasing the chunk size to 1,000, and the large margin M, the margin of M is to 0.8. Based on the methods introduced above, we show our results for task 1, fixed track. From the table, we can see that ResNet 101 and RepVGG A2 is the most promising single network for this track. The minimum cost after submean and AS norm is 0.3358 and 0.346. After fusion, the minimum cost of the reduced to 0.3185. We also present the ablation studies. We use ResNet 34 as our baseline, and we can make the conclusion that refinement can greatly improve the performance, and turning off subcenter on the in the stage 2 can give us some other improvements. Here is the results for the task 1 open track. We based on the observation from task 1 fixed track, we only use the 2 systems, ResNet 101 and RepVGG A2 for the open track. The minimum cost is 0.2384, and our system rank 1 first in this track. The bottom table shows the results for task 2 speaker retrieval, and the map using ResNet 101 is 0.6107. Sorry. The results using ResNet 101 is 0.6106. We also do a post-evaluation, and the results are posted here. Because the registration utterances are concatenated from short and different JARAs. So if we use the time step information, which is provided in the training and developing datasets, we can do split. We can split the long registration utterances into small short utterances, and do embedding average. We can see that the embedding average can greatly improve the performance. The minimum cost of the fusion system is 0.2914, surpassing the best minimum cost in the context. So also the embedding average can boost the minimum performance of OpenTrack. So the conclusions are listed here as follows. First, threefold speed augmentation and adaptive score normalization are effective. And two, domain mismatch degrades the performance. So in domain data for fine tuning is useful. And long duration the third one is long duration and large margin can improve system performances. And the last one is subcenter makes the model more robust. That's all. Thank you all.
Okay. Thank you very much, Dr. Xu. Yeah, congratulations again for the brilliant results. Let's see if any questions from our audience, from our guests. Okay. Yeah, let me ask a question about the OpenTrack results. I know that your company has lots of training data. Okay. Can you share some knowledge? How much did you use to boost the performance in the OpenTrack system?
Yeah, we can see from the table. We can see that ResNet 101, the minimum cost for fixed track is 0.33, and while for the OpenTrack, the minimum cost is 0.24. So I think it's roughly about 20 to 30% relative improvements.
Right. Yeah. I'm curious. How much data did you use, and what kind of data did you use to obtain such improvement?
Yeah, we use our internal large scale datasets, and it's roughly about 240 more than 200,000 number of IDs.
200,000.
Yes.
Okay. So that's reasonable. Okay.
Yeah, I think because of the data mismatch, so I think the performance degrades severely. Very much degrades very much, and so I think maybe if you have so many matched data, the performance will much better than the results we shows here, I think.
Right. Let me make it clear. Did you use that additional data to train the system from scratch, or using the data to conduct something like a pre-training and then use the in-domain data to do the refinement?
Actually, we only use the CELB E data for refinements. So we do not use our internal datasets for refinements. Yeah.
Okay. So use the internal data for the initial training.
Yeah.
Okay. That's nice. It's quite amazing. Right. Let's see if other questions from audience. Okay. Right. If no, thanks to Dr. Xu again, and congratulations again for the great improvement and achievement. Thank you very much.
Okay, thank you.